Think of the experience of flying through the empty vastness of the space at velocities that we cannot even imagine in our daily lives. A lone voyager of the galaxy, much older than the very system in which we live, and now, on a temporary visit to our own galaxy. This is what happened to 3I-ATLAS, the third object in the solar system ever to be confirmed as an interstellar. And it is keeping observatories all over the world these days with its mystery-like action as it speeds to a near miss with Mars. And ever wondered what the universe has still to know with our sun behind us? Then stay here today, and we are going to plunge deep into this interstellar comet, the unusual features it possesses, and the reason why it is creating such a commotion in the scientific community. By the time you finish this video, you will understand why 3I-ATLAS is not any ordinary space rock. It is a window into the history of our galaxy. In order to appreciate 3I-ATLAS, I would go back in time and look at the rarefied company it associates with. The solar system, comprising of planets, asteroids, and comets, is an overcrowded family house glued by the force of the sun. However, once in a while the party is interrupted by a crash-bang-bang of an outsider, a member of an alien star system thrown off, floating around the Milky Way millions of years before being shot through by gravity. The initial visitor, 3I-ATLAS, which was found in 2017 by the Pan-STARRS telescope in Hawaii, baffled scientists with its cigar-like form and absence of any visible coma, prompting them to engage in wild speculation about its origins. But it turned out to be a natural asteroid-like fragment. Then in 2019, 2I Borisov was discovered by the amateur astronomer Gennady Borisov, which acted more like a typical comet, with a tail of gas and dust as it neared the sun. These findings were revolutionary and realized that interstellar objects do not exist in theory, but they exist there, and they are much more abundant than we have imagined. Researchers such as David Jewett at UCLA estimate that on average, approximately 10,000 of these objects are present at any given time in the orbit of Neptune, and that each of them is a potential messenger of the far-off stars. Jump to July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a NASA-funded network of telescopes tasked with detecting potentially Earth-threatening asteroids, noticed a small blip in the heavens at its observatory in Rio Hurtado, Chile. Initially, it was merely another far body, however. As the numbers were crunched on its path, the buzz grew. This was not rotating around the sun like all the rest of the system. It was pushing its nose right in through interstellar space at a ludicrous speed of 60 kilometers a second. That is 130,000 miles an hour. It is more quickly moving than the escape velocity that it would require to get out of our solar system, which supports the extraterrestrial origins. On July 2, 2025, it was formally given the Minor Planet Center designation 3I-ATLAS because it is the third interstellar interloper. Imagine the following scenario. As exciting as it was, both Oumuamua and Borisov were detected to be on their outbound journey, and hence allowed us little time to study them, whereas 3I-ATLAS was discovered early in its outbound orbit, and this gave us scientists months of time to study it before it goes round the sun and heads back into the void. The first thing that catches the eye about 3I-ATLAS is that it is cometary in nature. This visitor is a comet, a frozen ball of ices, gases, rocks, and dust, unlike the rocky Oumuamua, and begins to become active when it approaches a star. The volatile materials are sublimated by solar heat, and the surface turns directly to gas, glowing into a coma, that hazy air, the one around the nucleus as well as a tail, blown away by the solar wind and radiation pressure. Initial observations with the ground telescopes, such as the Gemini South in Chile, revealed a wide, dusty coma. However, the real revelations were made by space telescopes. NASA Hubble Space Telescope captured a beautiful shot on July 21, 2025. 3I-ATLAS was approximately 277 million miles away. The photo showed a tear-shaped cloud of dust emerging out of the nucleus with traces of a tail developing. The information provided by Hubble in the article of the Astrophysical Day journal letters estimated the maximum diameter of the nucleus at approximately 3.5 miles or 5.6 kilometers, but could be as small as 1,000 feet in diameter, approximately the size of 3 football fields. That central nucleus is still obscured by the dusty veil, But the dust loss rate is such as would be caused by a comet at such a distance as by one of our own Oort clouds. Going into more detail on its composition, the NASA ESA CSA James Webb Space Telescope and NASA SphereX have come up with spectroscopic data that is quite interesting to say the least. They observed a high concentration of carbon dioxide, carbon monoxide and water ice in the coma. Gas is usually found in comets, but found here in unusual proportions. To provide an example, the proportion of carbon dioxide to water is far too large, which, according to astronomers such as Martin Cordner of the Goddard Space Flight Center, could be due to a dense crust of carbon dioxide on the surface that kept water ice eruptions down until the next close arrival of the Sun. The European Southern Observatory, using the Very Large Telescope in Chile, further complicated it by detecting nickel and iron in the coma, which are more common to asteroids and have to undergo extreme temperatures to be freed. But here they were, evaporating at almost 300 million miles away of the Sun, where it should not be a high temperature. One such theory is that these metals are fixed in volatile compounds such as carbonyls, which are relatively easier to break. The findings, as described in articles released on RSEV, can show how 3I-ATLAS are unlike solar system comets, which provides evidence as to the chemical diversity in other star systems. But composition is not an end of the intrigue. The most recent polarimetric measurements have discovered something really anomalous: extreme negative polarization. To explain this in a straightforward way, polarization is the extent to which light waves are scattered by the surface of an object, and they tell about the size of the dust grains on the surface of the object, the shape as well as the composition. A study by Z. Gray and others, currently posted to ARXiv as of September 2025, indicates that 3I-ATLAS has a polarization value of 2.77% at a low phase angle, and its inversion angle is only 17 degrees, the phase at which the polarization changes its direction to negative rather than positive. It has never happened before. There is no other comet or asteroid, be it interstellar or local, that portrays such extremes. In a Medium post, Harvard astrophysicist Avi Loeb points out that this, together with the retrograde orbit around the ecliptic plane, the orbital disk of our solar system, makes eyebrows go up. Random arriving interstellar visitors are supposed to hit at steeper angles statistically, but the path of 3I-ATLAS is tilted by a probability occurrence of less than 5 degrees, 1 in 500. Loeb warns that it might be natural, but these peculiarities hold the door open to the exotic explanations. Although mainstream opinion is that it is a comet, talking about its direction, we should track down on whence this heavenly vagrant emerged and whither it has been traveling. A mathematical team of researchers led by Xavier Perez Couto followed the path of 3I-ATLAS over 10 million years using data provided by the European Space Agency, Gaia Observatory, and found possible stellar interactions. But none of these occurred in such a manner that it had any appreciable effect on the path. Rather, it has been postulated to be formed in the thin disk of the Milky Way, possibly by the fragmentation of a primitive planetesimal disk in a galaxy that had been formed early in the history of the galaxy. The age of the universe, according to astronomer Matthew Hopkins of the University of Oxford, is estimated at between 7 to 8 billion years old, billions of years older than our own 4.6 billion-year-old solar system. Suppose that this comet may have observed the birth of millions of stars, floating through the interstellar clouds and remnants of supernovas, and leaving its particular fingerprint of chemical in the process. By September 14, 2025, 3I-ATLAS will be on a path speeding towards the Sun, which will last perihelion, the nearest approach to the Sun, in mid-October at 3I, at a distance approximately double that of Earth. However, the real star of this is that it rendezvous with Mars on October 3rd, when it will pass above at about 30 million kilometers, nearing the red planet, then the Earth. The Mars Reconnaissance Orbiter of NASA has a golden chance to observe the nucleus by peering into the coma with its high-rise camera due to such closeness, which might see the nucleus 3 times sharper than Hubble. Mars Express and ExoMars Trace Gas Orbiter will also participate in ESA and employ spectrometers such as NOMAD and CASSIS to examine the gases and images. In a quote in CBC News, James Ray of Georgia Tech emphasizes the excitement. It will get to Mars a lot closer than it will get to Earth, so one of the Mars cameras will have a higher resolution than Hubble. Subsequent NASA missions, such as the Psyche probe, and ESA missions, such as the JUICE probe, may capture glimpses in late 2025, with the data of JUICE trickling back by early 2026 because of its journey to Jupiter. These observations in the future are critical since 3I-ATLAS has already tossed curveballs. On the one hand, it has become more dusty, and there have been reports of an odd effect, known as an anti-tail or a glow that goes toward the Sun, in the opposite direction of one would have thought the tail to go. This is not new. It is occasioned by bigger dust particles remaining in the orbital plane that redistribute sunlight in a manner that generates this illusion as seen in the solar system comets such as Hale-Bopp. In an interstellar setting, it is new, however. Also, ground observations of a lunar eclipse in Namibia showed changes in the glow of the coma that could have been caused by the production of cyanide, but not a radical color shift, as the initial rumors contended. And as early size estimates were swelled up to 20 to 46 kilometers and made it seem impossible to have been natural, since the interstellar is short of huge interstellar lumps on this scale. The refined data provided by Hubble reined it, allaying these fears. Of course, with mysteries come myths, and it is worth bringing one of the big ones right into the spotlight, the fact that 3I-ATLAS may be an artificial probe or an alien artifact. With its queer course and polarization, theorists such as Avi Loeb have postulated technological origins, which they compared to the debate on Oumuamua. Nonetheless, despite this, as Northern Arizona University professor Christina Thomas told National Geographic, it is not in any way different lead paint. It is just a ball of evaporating ice. It has not been detected to be carrying any techno-signatures, including radio signals, and its behavior is also consistent with that of comets. It is further supported by the FAQ of ESA. It is not dangerous, being more than 240 million kilometers away, being in no danger as it is on the far side of the Sun during perihelion. Rejecting these myths keeps the eye on science, where 3I-ATLAS may show how elements such as carbon and metals were seeded on planets throughout the galaxy and may have helped put together the building blocks of life in case similar objects were trapped in the nebula of our own Sun. In the future, the 3I-ATLAS will disappear into the Sun in the near future, but will reappear in December 2025 and will be visible over a year as it leaves the solar system forever. There are now facilities such as the Vera C. Rubin Observatory, which has a sky-sweeping capability, which promise to notice more such visitors, models projecting one interstellar object per decade. This will be a breakthrough in the field of galactic chemistry and planet formation. It is flying extremely fast indeed. So David Jewett was interviewed on CBC saying, "The Sun cannot keep it. The gravity of the Sun cannot keep it. It is flying really, really fast." Simply put, 3I-ATLAS is a museum artifact, a reminder of times when the galaxy was young, of how closely connected the stellar systems are. That is a lot that I have discussed, and I want to conclude that I hope you are curious about the universe now. In the event that interstellar wanderers are as appealing to you as they are to me, like it, subscribe to further science voyages, and leave your ideas in the comments. Do you believe that we will have more interstellar wanderers like 3I-ATLAS very soon? Send this video to one of your space fans and continue to discuss it. Thanks, and that is all till next time. Keep looking up.